first small introduction, because it's not so general topic, it's mostly in context of this secondment within Photonic LV project. So basically it was involved with this GRC, which was one of the strategic partners. I went to the GRC Potsdam to work there, and Ivan Hoffman, who's actually from US, worked at this time at the GRC Potsdam as a guest scientist, and we agreed that he can come out and to help us with our timing system modernization. And so there is also some related issues, and so this is a review what we have done within the frame of these secondments. The modernization plan is a bit much bigger, sorry, it's too large to fit it, but basically the bright yellow part is what we are in process or already finished, and the rest is, well, it's an uncharted territory. Well, to summarize what we did, the first thing which was very obvious was about the timing system. What we need to know what we had before, and also the modernization. We were at the beginning about to purchase new times and frequency standards. So it was all to take a closer look what we have. Second was a bit more described in the presentation in the morning. It's also a bit involved this SLR system calibration, external, internal issues, because Potsdam operated the same telescope as we for 10 years very successfully, and they also have gathered a bit experience how to do some things. The other big item was data processing software. We are well, maybe a bit slowly, but moving forward. There is new functionality, we are now, okay, a bit more later, adding some new capabilities. And of course, the SLR station operational issues, which is, well, it's about the quality control and so on and so on, because it's also software related, because some procedures are noise in software, and second, the Potsdam operates probably one of the most advanced telescope control system in the world, designed by Spacetech GmbH. And we are now collaborating with Spacetech also to supply our processing software with their control system to finish new telescope, which is supposed to be delivered in second half of this year. This is the latest information. Okay, and now back to the timing system. Here is a small look of the old one. It's not a full rack, but it gives an impression what we have. It's from 20 years old or even more. The old rubidiums which are below was dated as 1988, and the rest is not much newer. And when we purchase and start to write specification for the new time standards, it's not so easy. You just look at a few numbers, write, and well, put and plug it, and it will work. It's not. So first, for a small introduction, there is a comparison of GPS disciplined oscillators by the National Institute of Standards in US. Unfortunately, they are not showing what companies are producing. This is just one aspect, it's about one deviations, but nevertheless the performance is quite a large variation. And even some of this number fortunately is printed in specification, but there are other, like the 1 second stability and accuracy. This is one thing is on paper, but what is in real life is completely different story. And when we had such a lucky coincidence that the Potsdam also has a primary time standard cesium, which was unoperational for a long time. Then they are intending to try the time transfer experiments. This is why Ivan Hoffman was there. And it turns out that first the cesium tube was already from timed out. They had to wait to deliver the new high precision cesium tube. The tube costs about 30,000 euros for cesium as a replacement. So if one wants to play with cesium, this has to be taken into account. But finally we get the cesium and we take one unit, bring to the Potsdam, make measurements. Then we bring one unit back, bring the second unit to Potsdam and make the repeated measurements. And then after this analysis, we also made a presentation for the ILRS workshop at Annapolis, which the final paper is currently under process. We are just putting everything together. But here will be some small result. Another note, this testing not taking by cannot be done for one day. It takes weeks or even months to properly test these things. Because for these types of time standards, you have a basic level you can reach within 24 hours. To make already some manufacturer recommendation takes 2 weeks of permanent on. And only after that you can rely that your measurements will be more or less reaching the maximum accuracy. Actually, in this NIST paper, they are claiming that it may take about up to the 2 months to get the optimum performance from the time standards. So our measurements probably will fit only the middle criteria, this 2 weeks warm up. And here are a few charts. This is one Allen deviations when compared with the cesium. Well, and at the top is our poor rubidium, which is okay. This is simulated against rubidium, it's not against the cesium. But more or less, 10 MHz output of our GPS field, the rubidium clocks is, well, at least more or less corresponds to the official specification. Now we'll take a look on the 1 second output, and here it turns out very interesting picture. It turns out that there is a bug in the software and it oscillates with a 5 nanosecond step, the 1 PPS output. We contacted the manufacturer, they slightly before Christmas, they answered, yes, this is a bug in the software, probably. This is they are expecting to be fixed in the January of this year. So, well, January is over, fix is not, but as with engineers, if we multiply the number by P, we will get the approximate date. So I expect it March somewhere, it could be. But that is not a really big issue, because really only for high accuracy, really high accuracy measurements which approach cesium. And at the moment, this is not critical for us. And the second thing, the rest of the functionality, the frequency source is functioning properly. That's a good thing. There is some other nice things, and when we make another comparison with Potsdam current time standard, which uses quartz oscillator double oven, it turns out that this double oven quartz can make even 100 nanosecond error in UTC. Here we are in absolute, not the RMS. Here it's 50, 60, something like that. So it's pretty good for this type of devices. And here is how it looks like. The new one is on the bottom, so from all the big rack, basically there is one box and one distribution amplifier. Well, some words about this new date processing software. So what was some important part? We first wanted to add, this was for Potsdam, because they are all trying to track dysfunctional satellite to determine the rotational parameters, and one of the famous examples was Envisat, which is now out of order. It nicely tumbles in the orbit, but you cannot process it as a standard procedure because this amplitude distance variation is too large for the classical fitting. So we managed to implement it. The same idea used is in Graz. It's an orthogonal polynomial fitting with some tricks added. The another work was this integration with the scope. This is what I mentioned, this telescope control software. So we were trying to adjust also this both parts, the date processing and telescope control, so it worked better together. It involves also support for the space debris tracking, and it in turn means this is support for bistatic ranging. It means we are doing either only getting the signal, so it means all this post-processing is okay, it's not completely different, but there is more than small difference. And also all these scenarios, we are shooting and getting back, we are just shooting, or we are just getting signal from station who is illuminating the satellite from completely different place on Earth. So this work is currently under the way. And okay, here is a small illustration. It's not unfortunately, I showed yesterday NVSAT tracking to colleagues, but the picture is wrong. It's not NVSAT where I wanted to show these nice waves, and this is a bit different one, but it's just a reminder how it looks like. Well, and now a few words about future, because it goes out slightly from this context, but nevertheless, this is a near performance, let's say, for the next months. We want to get, we just finished, with help with the Ukrainian colleagues, to characterize our measuring equipment, including event timers, PMTs, and associated electronics. Finalize all the calibration for constants and also this amplitude correction functions, which is actually quite specific thing. I think we are probably the only station in the world who are trying to use this way. It's okay, from one point of view it maybe sounds good, from other it's not so. Also improve optical alignment instrumentation, which, well, we wish to be better. And we will try to install the CCD in the telescope visual tracking channel. The option also, it could be operated as an independent receiver channel, so we can play with the detectors and maybe have a slightly better receiver channel efficiency. And also the first experiments in space debris tracking. Of course, we will not shoot, we will just watch, because to shoot for the space debris with a laser, you need very high tracking accuracy, otherwise there is no chance. Well, and
this last point, when you expect?
This one we will try. I already have the tracking, we just have to close for watching, we will try. The another thing is detecting part, but first we should check the visibility, because there also is not so easy as it sounds. Well, in the future, what we are looking for, this is space debris and dysfunctional satellite tracking. This is actually quite a hot topic, because they are observing and looking on the satellite rotation. It's possible to determine it. So there is a lot of dysfunctional satellites on the list. There is some tricks with the processing, but it can be done. And of course, one has to get the returns. The big issue is the control system modernization. We had some remote chance to get the scope software, but to do this, we first need to do our homework with electronics. If the electronics is ready, then the scope, we already have the preliminary agreement, we will get it. And the third one is, because also a new topic, and already somebody is trying, because many neodymium YAG lasers already have its primary harmonics to try to range it. It's already in Graz are going the first experiments. I think very soon Ben Green in Australia have already done this, so it works, but he is not publishing his results for obvious reasons. And yeah, and that's it. Thank you for your attention.